All right, now what am I going to have to do? 100 centimeters, is it a meter? Now take a look at that. You see how mine's multi-step? Fine. Okay, I understand that. I understand this lady did it in one step. But who wants to remember that thing off the top of their head, right? Hey, you may say, well, Joe, I thought you said that if we needed some of these conversions that I would provide them for you. Well, okay, that's great. But am I going to provide them on your MCAT test? Am I going to provide them on your PCAT test when you're trying to get into pharmacy school? No. All right. So you need to be thinking about ease of remembering. So let's go ahead and do it here. 100 divided by 52 and times 60 times 3 times 12 times 2.54 divided by 100. 105.5. Well, look at that. Did I get the same answer? Yeah. I mean, within reason, right? You get out here to the thousandths place, it's a smidge different. Okay, which one do you think is the most accurate? The bottom one or the top one? The bottom one. Why? Because every single thing in the bottom one there is an exact number. This is an approximation. Now, is it close? Sure, right? Who even cares about a distance in a thousandth of a meter? All right? But this is the most exact. Again, this is why on these tests I grade them. It takes me a while to grade them because every person could do it different. You get the same answer. Yeah, there you go. Did hers with a yard in it. So it doesn't matter. Doesn't matter. It depends on what you're given. All right. I had a math professor in college that used to say, the more you know, the lazier you can be. All right? Because think about it. If you are a real chemist or a real person and you do the conversion, some joker would have had to have went and looked that up. I wouldn't have had to look up anything, right? I could have just sat there and drunk my coffee and ate my donut. So, whatever you want to do. What do we got else? We got something else? All right.
It's going to seem easy, but it was number 20H.
20H. 9 microliters to milliliters? Wonderful. Microliters to milliliters, right? Okay, so 9 microliters to milliliters. All right, 9 microliters to milliliters. All right, so first thing I'm going to do is I'm going to write down what I'm given because I know that that can't be wrong. Okay? Now let's deal with the units. What unit am I going to put down here? Microliters, right? And there's one small answer why that is, because it cancels. Okay? Now what unit goes up here? Liters, right? Because that base. That single letter in this particular classroom here, that single letter unit, the base, is where we need to go. All right? Now, in 1 microliter, how many liters are there? -6. 10 to the -6. 10 to the 9 is a nano. All right? So 10 to the -6 is a micro. Now, liters are on the bottom, right? Because I want it to cancel. And what goes on the top? Milliliters. Okay, so on 1 milliliter, how many liters do we have? 10 to the -3, right? Where are these people spitting these numbers out of? They're spitting the numbers out of the table, right? Because they know they got to know the table. And anytime you use the table way in our book, the numbers always go with the single letter. The numbers always go with the single letter if you're using your book. Now, some of you guys may take advantage of going to a tutor session or place. Now, they got wonderful tables there, but sometimes the table's flipped. In other words, you would use 10 to the 3 next to the milli part, not 10 to the -3. So I have to keep stressing that when you're using your book's method, okay, divided by 1 times 10 to the -3, 0.009? 9 times 10 to the minus 3. That's right. 3 little bounces. 1, 2, 3. 0.009 milliliters. So that's a small amount. You know, as I told you before, if I had a microliter pipette, okay, and I took and I did like that and pushed the DNA toward her, I mean, it would practically evaporate before it even got to her face. A microliter is a tiny amount. I mean, it's way down here in the thousandths place of a milliliter. All right? So, and if you put a microliter on the desktop, I mean, could you see liquid? Yeah, you could get down there and look at it, but it would certainly not be a huge amount. What else do we have? What's that now? What's that?
I did it a lot different. You got the same answer. I guess it's right.
Yeah, well, tell me what you did. We'll throw it up there.
I put .000001
We're here.
on the top.
0.00001. Yep.
Microliter and then .001 milliliter. Divided it, multiplied it by 9, came up with .009.
Yep. That'll work. See, that's just it. There are so many different ways to work a problem. The only thing you cannot do is violate math or physics. All right? Or you can't just get an answer that happens to be right, but you're pathologically wrong. All right? In other words, you just coincidentally got the right answer because you were lucky, right? Now, this here is not that situation. All right? Anybody got anything else? 28.
28.
Oh, 20A. Okay, 4.5 centimeters to angstroms. Okay. So, so 4.5 centimeters going to angstroms. Now, an angstrom is a tiny unit of measurement. We're talking about measuring across atoms. We're talking about measuring bonds, like distances between atoms. You know, very, very tiny amounts, something you cannot see, even with a microscope. Now, I mean, there are certain types of AFMs, the atomic force microscopy, and things like that. You can see some of these distances, but a normal person would not. All right? So, 4.5 centimeters. All right. Now, look at the back of the book and tell me what an angstrom is. 10 to the negative 10 meters. So how am I going to get centimeters to meters? What's that?
I'm going to put, the first one is 1 times 10 to the negative 2.
Here? Top. 1 times 10 to the negative 2, right? What's she doing? She's putting the number in the table next to the single letter. All right, that's Jim Dandy. All right, now let's look at here. 1 times 10 to the minus 10 meters. We'll cancel there and 1 angstrom. Okay. Typing that in, what are you going to get?
I have 4.5 times 10, 8, whatever you call it.
10 to the 8 angstroms?
Yes.
All right. Well, I'm getting confident in you guys now, right? Maybe I shouldn't start trusting you, but I'm going to trust you unless someone starts throwing a fit. I'll buy that. That is certainly a big number. That's almost a billion. And I would think that in 4.5 centimeters, you're definitely going to line up well over a billion atoms, or around a billion atoms. Okay? Does anybody have anything else? Is that what you got too? All right. Has anybody got anything else? Alrighty, that's wonderful. Okay, now let's talk about temperatures. Did we talk about temperatures last time? Oh, you just looked at me funny, like, are we going to do that again? What do you want to do now?
32.
Number 32? Sure. We'll do it. We'll do anything you want. 32. This is my favorite part of the class, by the way, because I just get to be put on the spot.